Hi, welcome back. In our previous video, we explored the architecture of our multilingual support system. Today, we are going to roll up our sleeves and set up the development environment. Before we dive into the implementation, let's understand some core concepts that make our multilingual support system possible. First, let's understand how a foundation model handles configuration and deployment in a production environment. When deploying large language models, we need to consider three critical components. First, the model weights. These are the parameters learned during training. Think of them like the knowledge a model has gained. But these weights can be very huge, often hundreds of gigabytes. Second is the model configuration. This defines how our model processes inputs and generates outputs. It includes things like context, length, sampling parameters, and model architecture details. Third is the runtime environment. This is where a model actually runs. We need specific hardware configurations, memory management, and efficient input or output handling. In AWS, this translates to three key services we'll be using. First is Amazon S3, which will store our model artifacts and the LoRA adapters. Second is SageMaker, which will handle the model deployment and the runtime. Third is IAM, which will manage permissions and security. Before we dive into the code, we need to set up our AWS environment. Let me first walk you through that. I'm logging into the AWS console. We'll need several services for our project. First, we'll use SageMaker as our main platform for deploying our models. Second, we'll implement the S3 bucket setup. We need a place to store our LoRA adapters and model artifacts. So let's create a S3 bucket to store them. Before we dive into the configuration code, let's understand something very crucial about the model configuration. When working with large language models, we have two types of configurations. One is the static configuration, which contains things like the model architecture and adapter locations. Second is dynamic configuration. This will contain runtime parameters like temperature and sampling. Now that we understand these concepts, let's set up our project. We'll start with the requirements file. This file lists all the Python packages needed to run our project. We need AWS related packages like Boto3 and SageMaker to interact with AWS services. Machine learning packages like Pandas, NumPy, Transformers, and Torch that handle our model operations and data processing. The Hugging Face Hub package lets us access our base model and LoRa adapters. Additional utilities like YML and Python.env help with configuration management. When you want to run the project, just simply install these dependencies with the proper compatible versions and you should be ready to get started. Now let's look at our AWS configuration. We are first setting a dictionary with our AWS region and the IAM role ARN that we created for our SageMaker execution role. Your role ARN should look something like this. Next, this configuration defines our base model settings. The model ID specifies which model to load from Hugging Face. The instance type of MLG52X large specifies our AWS compute resources. G5 instances use NVIDIA A10G GPUs, which is important for running language models efficiently. Next, this section defines our language adapters. Each adapter requires two identifiers. One is the name, which defines a standardized language code. The adapter ID is the identifier for loading adapter weights. Then we are defining domain adapters that specialize in different support areas. Now that we have covered our LoRa adapter configuration, let's dive into the SageMaker deployment configuration. These settings determine how our model will be deployed and accessed in AWS SageMaker. We set a unique endpoint name for our application so that when applications or services want to use our multilingual support system, they'll use this name to find and connect to it. The container version specifies which version of Amazon large model inference container we are using. LMI containers are specialized software packages that AWS provides for deploying large language models. This version includes important features we need for our LoRa adapters, and it has been proven to be a stable version. Next, the maximum concurrent transforms controls how many requests our system can process simultaneously. Setting this to 4 means our system can handle 4 customer queries at the same time. This is important for managing our system's resources and ensuring good response times. If we set this too high, we might overload our GPU and slow down all responses. If we set it too low, customers might have to wait unnecessarily. Next, enable unmerged LoRA is a key optimization feature in SageMaker. When this is set to true, Instead of merging LoRa adapters with the base model, which would create separate copies for each language, SageMaker keeps adapters separate and loads them dynamically. This drastically reduces memory usage since we only need one copy of our base model. The maximum LoRa rank specifies the size of our LoRa adapters. The rank of 64 was recommended in a tutorial I watched earlier for balancing adapter size and performance. A higher rank means larger, potentially more capable adapters, but it requires more memory. Low rank means smaller adapters, but it might affect quality. The maximum CPU LoRa is particularly interesting because it tells SageMaker how many adapters we want to cache in our CPU memory. When we set this to 4, SageMaker can store up to 4 adapters in CPU memory. If a rarely used adapter is needed, SageMaker swaps it with a more frequently used one in GPU memory. This dynamic loading mechanism helps us support many languages efficiently even with limited GPU memory. Here, when I say languages, I mean the languages that we use for our customer support like English, French or Russian. Now let us dive into the environment variables. First, the tensor parallel degree is set to maximum. This means that when running large language models, we can split them across multiple GPUs to handle their size. By setting this to maximum, we are telling SageMaker to use all the available GPUs. Next, we have the rolling batch variable. Rolling batch enables SageMaker's dynamic batching, which is essential for handling multiple customer queries efficiently. By setting it to auto, SageMaker optimizes how it groups incoming requests, while maximum rolling batch size ensures we don't overload our GPU. Imagine a customer support center where multiple customers are asking questions simultaneously. Instead of processing each request one by one, rolling batch allows us to group these requests together. Setting it to auto lets SageMaker automatically determine the best way to batch requests. The maximum input length and the maximum total tokens control the text length limitations. The input length of 2048 means we can process customer messages up to 2048 tokens long, which is roughly 1500 to 2000 words. The total tokens limit of 4098 includes both the customer's message and our model's response. These limits help prevent memory overload and ensure consistent response times. Without these limits, very long messages could crash our system or cause extremely slow responses. This is our Hugging Face access token, which you can get from your Hugging Face account. And at last, we have the data type, which is set to FP16. This relates to how numbers are stored in our model. Traditional computing uses 32 bits, which is FP32, which provides high precision but consuming more memory. By using FP16, we cut memory usage in half while maintaining sufficient accuracy for our language processing. This is particularly important because language models need to store millions or even billions of numbers. Setting these parameters right is very essential because they directly impact our system's performance, reliability, and cost efficiency. They help us balance between speed, quality, and resource usage. At last, we have the S3 setup configuration, which creates the storage structure needed for our customer support system. Amazon S3 is where we'll store all our LoRa adapters. Let's quickly look into how we categorize our storage area. This script creates two important storage areas. First, it identifies the default SageMaker bucket that AWS automatically provides. Then it creates a separate bucket specifically for our LoRa adapters. Inside this LoRa bucket, we create a structured folder system, separate folders for each language like Spanish, French, or Russian, and each support domain like technical, billing, or product. This organization will help us manage our different adapters efficiently, keeping language-specific and domain-specific components neatly organized. Before we wrap up, make sure that you have the IAM permissions set properly and have the necessary instance limits. These are some of the common issues that people usually encounter. So make sure that they are set properly. That wraps up our environment set. In the next video, we'll implement our LoRa adapters and start building the language processing pipeline. If you're following along and if you run into any issues, drop a comment below. Also, you can find all this code in the description below in our GitHub repository. Don't forget to like and subscribe to catch up on our next video about LoRa implementation. See you until then.